The idea of the in-wheel motor was first proposed by Ferdinand Porsche, an engineering genius and automaking pioneer. This electric car, built by Porsche in 1900, was powered by in-wheel motors. The round housings inside the wheels are the motors. When he built this car, Porsche was focused not on cars with internal combustion engines, but on electric cars. A great exposition was held in Paris in 1900. It was here that Porsche presented his electric car to the world. It had a top speed of 50 kilometers per hour and could run 50 kilometers on one charge. For the time, this was revolutionary performance. The car won the prestigious Grand Prize in Paris. Electric cars actually have a longer history than engine-powered cars. They were common on city streets early in the 20th century. Electric cars didn't vibrate much, and they were quiet. At one time, they outnumbered engine-powered cars in Europe and America. But thanks to a production method invented by American car maker Henry Ford, engine-powered cars rapidly grew in popularity. Ford's assembly line system made mass production possible, dramatically reducing costs. The performance of engines also improved. And in the early years of the 20th century, oil was discovered in many parts of the world. It provided cheap fuel that could be supplied in huge quantities. While engine-powered cars quickly became more numerous, no advances were made in batteries and motors, and interest in electric cars waned. It's been 100 years since cars with gasoline engines took the world by storm. Now society is turning a critical eye on engine-powered vehicles. As air pollution and global warming worsen, there's a growing shift from engine-powered vehicles to eco-cars. Automakers are now in a life-or-death struggle to develop next-generation cars that dispense with internal combustion engines. This is a hybrid car, which combines an engine with an electric motor to achieve major reductions in emissions. Hybrids are much gentler on the environment than conventional cars, so they're starting to become popular. The symbol of future eco cars is the fuel cell car, which extracts energy from a reaction between oxygen and hydrogen. Many hurdles related to production costs and handling of hydrogen must be overcome. It will be a while before fuel cell cars become common. Shimizu is working to achieve a resurgence of rechargeable electric cars. Advances in motors and batteries are close to making electric cars practical. If electric cars can surpass engine-powered cars in power and speed, they'll reclaim the market, according to Shimizu. It's a dream of a return to the preeminence that electric cars once enjoyed. Construction of the Eliica electric car now approaches the most crucial challenge: a high-speed running test for the motors. For the Eliica to reach 400 kilometers per hour, each motor will have to run at 12,000 revolutions per minute. It's possible to adjust the speed of an electric car by simply regulating the current flowing into the motors. The crucial regulating component is called an inverter. No one has ever before made an inverter capable of controlling a compact motor producing 80 horsepower and running it over 10,000 RPM. The challenge is tackled by a 50-person company that makes inverters for industrial robots and machine tools. The company has never been involved with the car industry. Japanese inverter technology is considered the best in the world. It has become the focus of Shimizu's attention. The motor spins up smoothly past 8,000 RPM. But just before 10,000, something goes wrong. The motor stops. How exactly does the inverter perform the difficult task of controlling a motor as it runs at high speeds? The inverter monitors the positions of the magnets. It uses this information to calculate how much current the coils require and instantly issues the necessary commands. The faster the motor runs, the more crucial is the time lag between taking a measurement and issuing a command. Time lags were calculated in advance and factored into the inverter's programming. But when the speed approached 10,000 RPM, a voltage built up inside the motor, and a phenomenon that could not be understood using known theory made the motor stop. The engineers had plunged into an unknown realm where theory no longer held up. They struggled onward. Japan's bullet trains are famous for their high speed. That speed also comes from high-performance motors and inverters. The bullet train's motors have a maximum speed of 6,000 RPM. The 12,000 RPM that Shimizu and his colleagues targeted was new, uncharted territory. Developing the Eliica meant figuring out how to control motors running twice as fast as those on the bullet train. Known theory could not explain why the motor had stopped during the test. So the team discarded the theory and powered up the motor. They decided to tweak the parameters by hand to figure out how to run the motor most smoothly, and then modify the inverter program accordingly. It's time to run the motor using the modified program. Once again, the team aims for the unknown territory, around 12,000 RPM. The motor speed rises smoothly past 10,000 RPM, then climbs past the 12,000 RPM mark. At last, they've succeeded in controlling the motor at unprecedentedly high speeds.
いや、やっとほっとしました。最高まで行けたんで、とりあえずまあ大丈夫か、今のところは大丈夫かなという感じですね。
一番大事なところが OK ということですんで、これはこれで一安心です。ですから30分前とは態度がだいぶ変わりました。